As communications engineers, we spend our entire careers fighting to get signals out. We calculate link budgets to reach satellites. We model ionospheric skip to talk across oceans. And we peer into the deep cosmos using radio telescopes. But what if the atmosphere stopped cooperating? What if, instead of being transparent to radio waves, the very air we breathe became a planetary-scale shield? Today, we're looking at a world where Earth's atmosphere is saturated with a stable, conductive metallic aerosol. A world where the sky isn't a window, but a mirror. Welcome to the Faraday cage Earth. In our current reality, radio waves, depending on their frequency, either pass through or refract. But if we introduce a high density of conductive metallic, nanodust, let's say aluminum or silver vapors, the physics of the sky changes fundamentally. This creates what we call plasma frequency at the surface level. In our world, the ionosphere does this for HF signals, reflecting them back to Earth. But in this scenario, that critical frequency drops into the gigahertz range. Anything above that frequency doesn't just get attenuated, it's reflected. The sky becomes a global Faraday cage. The most immediate impact? Total space isolation. GPS? Gone. Without a line-of-sight signal from the 20,000 kilometers altitude satellites, your phone has no idea where it is. Satellite internet like Starlink? Impossible. The signals would simply bounce off the upper troposphere and splash back down like water hitting a ceiling. But for us engineers, the real nightmare is telemetry. How do you launch a rocket when you can't talk to it? You can't command a stage separation or adjust a trajectory from the ground. Space exploration would revert to the 1940s, purely mechanical, set it and forget it ballistic flights. We wouldn't be a spacefaring civilization. We'd be radio hermits, trapped in a metallic bubble. We would live in a whispering gallery where every signal VHF, UHF, maybe even microwaves stays trapped on the surface. But there's a catch. A conductive atmosphere means the Earth's electrical circuit is short-circuited. Normally, there's a 300,000 volt potential difference between the ground and the ionosphere. In a metallic atmosphere, that energy wants to move. We wouldn't just have occasional lightning. We would have a constant corona discharge. Every antenna, every power line, and every skyscraper would hum with St. Elmo's fire. A permanent purple glow as the atmosphere tries to equalize its charge. Grounding wouldn't just be a safety protocol. It would be a survival requirement for all electronics. This what if shows us just how much we take the transparency of our universe for granted. We live in a rare window where the laws of physics allow us to see the stars and talk to our machines in orbit. If our sky turned to metal, we'd have the most perfect global radio network in history. But we'd be a civilization that forgot what the moon looked like. Thanks for watching this deep dive on Apex Vector.